Okay, so this is going to be just a review of how to solve systems of equations in the three different methods that we've learned: graphing, substitution, and elimination. So the first one we're going to solve by graphing. You can use other forms if you want to, but I'm going to get both those into slope-intercept form. The first one is already in slope-intercept form because y is by itself. The second one, I want to get y by itself, so I really just want to add over that negative 3x. So to cancel out the negative 3x, I'm going to do plus 3x and plus 3x. That gives me y equals 3x minus 5. Those are both in slope-intercept form. If you need to, you can use the calculator to help you graph those two. Once you get them into slope-intercept, the calculator will graph them, and if you know how to use it, it will find the intersection for you. I'm going to graph these both by hand because they'll actually both fit on the graph. Negative 1 is my y-intercept for the first one, and that has a slope of negative 1, which is a rise of negative 1 and a run of positive. So that means from this spot, I'm going down 1 over 1, down 1 over 1, and I'm going to continue to run across the graph back. The second one has a slope of 3 and a y-intercept of negative 5. So I start at negative 5, and from there I have a slope of 3, which is 3 over 1. So I'm going to go up 3, I'm going to rise of 3, and over 1 spot, up 1, 2, 3, over 1, up 1, 2, 3, over 1. Actually, you can see right from that second point, we have our solution. Our intersection of those two lines is at 1, negative 2. The solution to a system of equations is wherever the lines meet, wherever those two lines intersect. On the second one, I still want to solve these by graphing, so I need to get y by itself in the first one. I have to get rid of this multiplying by 2, so I'm going to divide by 2 and divide by 2. Y equals negative 3 over 2 times x. That has a slope of negative 3 over 2. And no apparent y-intercept, so the y-intercept is actually 0. That means it's starting at the origin. And from there, I'm going to count out my rise and run, a rise of negative 3 and a run of 2. Down 3, over 2. Down 3, over 2. That's my first one. My second one is just x equals 4. So x is always equal to 4. There is no slope in that line. There's actually no apparent y-intercept and no y-intercept at all. It's just telling me that x is 4. So I'm going to look at this as a table. I'm going to think about if all the x values were 4, 4, 0, or 4, negative, let's use negative 6 strategically, and then 4, negative 2. 4, 0, 4, negative 6, 4, negative 2. This is a vertical line that passes through all the x values that are 4. And it's kind of clear in the original equation, there is no slope to this. There's no slope at all. It's not that the slope is 0, it's that there actually is no slope. It's an undefined slope that passes through all the x coordinates where 4 is the x value. Those two lines are going to meet at this point down here, which I picked out right there. That's 4, negative 6. Alright, the next two I'm going to solve using elimination. The first one is a word problem that I need to translate into a system of equations, which means I'm going to get two different equations, and then I'm going to use elimination. You're planning a huge graduation party. You decide to offer beef and chicken meal options. The chicken dish costs $5. The beef dish costs $7. There will be 250 people altogether. We're going to assume that everybody's getting at least, well, just the one meal. And the total cost is $1,500. I've underlined these in the right colors strategically. We're talking about the cost of the chicken and the cost of the beef. That adds up to a total cost of $1,500. Cost of the chicken plus the cost of the beef is the total cost. The one I underlined in green actually tells us a whole separate equation. That 250 is all that we need, because we know that the chicken dishes plus the beef dishes, all of those together, is 250. Chicken plus the beef, we're calling chicken X here, and beef Y. Those together are going to feed these 250 people. Now I want to use elimination, so I want to either cancel out the X or the Y. It doesn't actually matter. I'm going to cancel out the X just because I can see that clearly. I want to cancel out this 5X. I'm going to multiply this entire equation times -5. I'm going to need some more room, so I'm going to actually erase my original equation and multiply that by -5. It gives me -5X minus 5Y equals -1,250. The elimination step is about to happen. That's the whole reason I really multiplied by the -5, so that I would be able to cancel out or eliminate one of my variables. Now I'm going to cancel out the 5x and -5x. I'm adding these together. I'm going to add those straight down and add these straight down, and keep the equal sign right where it is. That gives me 2y equals 250. And one more step to solve for y. I divide by 2, that tells me 125. I know that there's 250 people altogether. My first equation was, sorry, my second equation really, was x plus y equals 250. Well, now I know that y is 125. So I'm just going to solve for the x by subtracting that over, and actually x happens to be 125 also. So there were the same number of chicken and beef meals that were ordered. Next one, I want to do the exact same thing where I cancel out one of the variables. I only really need to multiply the top one by something. I'm going to multiply the entire top equation times a -2. I'm multiplying by a -2 so that it's the opposite sign of the x in the other equation. Right now I have a -12 for this second equation. I want to change the first one into a positive 12, so I'm going to multiply into everything into that equation. That's 12x minus 10y equals -2. Now I can use the elimination step where I add these together. I'm going to get -18y and 18 on the other side of the equal sign. That's 20 and a -2 combined to make 18. Last step, I'm going to divide by that -18 into both sides, so y equals -1. Now you take that and you plug it into either equation, it doesn't really matter. I'm going to use the first one, -6x plus 5 times this is going in place of the y, that's -1, and that equals. Gives me -6x minus 5, I'm just multiplying those two together just to turn it into one number. Really, I'm just simplifying that to make it into one number. Now I have a two-step equation that I know how to solve. I'm going to add the 5 over to make it 6. Show that. Add 5 over. Gives me -6x equals 6. And then I divide by -6. And x equals -1. So the ordered pair that is the solution to this system is -1, -1. Last one. Last method of solving is substitution. So here I'm going to take an expression for one of the variables and put it in place of that variable in another equation. As a salesperson, you're given a choice between two different compensation plans. Plan A pays a weekly salary of $250 plus a commission of $25 for each cell phone sold. Plan B pays no weekly salary, but it pays $50 for each cell phone sold. How many cell phones must you sell to make the same amount of money with both plans? Actually, we really don't even need two equations for this. I'll talk about that step later. But which plan would you choose and why? That's going to come in later once we figure out how many cell phones it actually takes to make these plans the same. So right now I want to think about what are my two things that I don't know. It's really the money that you're making from each plan, which I'm going to call Y, and the number of cell phones that you're selling. I'm going to call that X. Oops, I wrote Y. So we're talking about how many cell phones we can sell, and then eventually how much money we can make from those cell phones. So really, it's just how much money we're making, how many cell phones we're selling. That's what I'm going to label as my X and my Y. So for plan A, the total amount of money that I'm making comes from the 250. That's the money I'm making no matter what. That's what a weekly salary is. I'm just getting paid that plus the commission for each cell phone sold. $25 times the number of cell phones. Plan B is making $50 for each cell phone. There is no weekly salary, so I don't have a number that's being added up. I'm going to use substitution here. I'm going to take the 50x here and just throw it in place of that y in the other equation. I know y equals 50x, so in my first equation, I can just change that y into a 50x. And actually, we've seen equations like that before, where we haven't needed to actually set up two equations. That equation models the entire situation. We want to know when these two plans are equal, when 50x equals 250 plus 25x. So we actually didn't even need the two equations technically there. We could have just written that as one equation. From there, I'm going to solve for x. I need to combine my x's to the same side. So first, I need to minus the 25x from both sides. That gives me 25x equals 250, and x has to be 10. We divide by the 25 to get that x is 10. In this case, I actually don't need to find my y. I could plug that back in and find that y is 500. But the question is just asking for the number of cell phones. It's not asking for the money that we're making. The y represents how much money we make. So we make $500 from both plans when we sell 10 cell phones. This is really the final answer. This is all we need. It's talking about the number of cell phones. I found that with my x. Personally, I would probably pick the second one, because if I sell an 11th cell phone, that would make me $550. Whereas the other one, I would make $525. So once I sell more than 10 cell phones, I start making more money with plan B. I think I could sell 10 cell phones in a week. That's less than 2 per day. I think that's pretty manageable. So I'd probably pick B. But really, we're just thinking about when those plans even out and how much money we're making from each of those when we are selling a certain number of cell phones. Number 6, I need to use substitution, so I have to solve for one of those variables. I'm going to solve for y in the bottom. I'm going to add the 3x over to the other side. It gives me that y equals 3x plus 5. Now I can use substitution. It might have been easier to use elimination on there, but I'm going to use substitution by taking that whole expression, plugging it in place of y. So that gives me 8x plus 3x plus 5. Normally you'll see that expression plugged in parentheses, but I'm not multiplying by anything. I don't need to distribute anything there. It's just y by itself, so I'm just going to write it as 3x plus 5. Now I combine my terms, so that's 11x plus 5 equals negative 16. Oh, I'm sorry, that's a negative 5. I was saying that is not going to work out to a nice number. That is actually a negative 5. Which is going to make this much nicer because I'm going to add 5x, sorry, just 5 to both sides. Gives me 11x equals negative 11. So x is a negative 1. I'm going to take that and plug it into either equation. I'm going to take negative 1, plug it in either here or here to solve for the y. I'm going to plug it into the top one. It would be negative 8. That's 8 times negative 1 plus y equals negative 16. I add 8 over, and that gives me that y is negative 8. And that's my solution to the system of equations.